Hey guys, this is your second Algebra 2 video to round out our first unit. Time flies. It's a speedy one. So this is absolute value equations and inequalities. You've got the notes in your packet. You can also see them on my screen, and we're going to work through them together so you can understand how to solve absolute value equations as well as absolute value inequalities. You may recall from algebra what absolute value is. You've got it living inside those fancy brackets. As you can see right here, the absolute value of x plus 2. And what is absolute value? So absolute value, I'm going to draw a little picture, signifies the distance of a number in units from 0 on the number line. So if my number is 1, this is 1 unit away from 0. Well, this is also 1 unit away from 0. There's no negative absolute value because absolute value does not signify the direction that you're moving away from 0. It only signifies the distance. If you are driving in your car and you go 10 miles east, well, 10 miles east or 10 miles west, it's still 10 miles. It doesn't matter. Miles is the distance. It doesn't matter if it's east or west. Just like 1 unit is the distance, it doesn't matter if it's to the right or to the left, to the positive or to the negative. So there's no negative absolute value. And this is the reason why in the end of all of this, when we drop the absolute value brackets, if there is a negative number inside, the absolute value of that number will be the positive version of that number. So negatives are not invited to this party at the end. They're coming to the beginning. They're going to stick around for a little while, but then they will not be the last man standing. So how do we figure out the absolute value of a variable when it's stuck in the middle of an equation? There's always going to be 2 answers to an absolute value equation, but each of those answers, each of those solutions might not work. So you, everybody's favorite thing, must check. You must check your answers. Why did I go out? There we go. You must check your answers. And every absolute value problem gets solved twice, and you'll see what I mean about that in one moment. One of the versions will be as is without the brackets, and then one, sorry, this typo, with the right side of the equal sign negated without the brackets. So what does that mean? We're going to use the example of the absolute value of x plus 2 equals 6. When you are reading these problems, anything inside the brackets you refer to as the absolute value of that thing. So x plus 2 equals 6. We're going to branch out here, okay? And we're going to write our 2 solving equations because remember, every absolute value problem gets solved what? 2 times. I really need like a studio track or something for responses here because I'm just doing this alone in my kitchen and it doesn't get the same response. All right, so once we're going to drop the brackets and rewrite it as is, x plus 2 equals 6. I really hate how this is making it go out of focus every time I put my hand in the frame. All right, and then the other side, we're going to drop the brackets and we're going to negate the right-hand side of the equal sign. So we get x plus 2 equals negative 6. Now we're going to go ahead and solve both of these. X plus 2 equals 6. Well, we have to subtract 2 from both sides to get x equals 4. All right, no big deal. X plus 2 equals negative 6. We're going to subtract 2, and that's going to give us x equals, what's negative 6 minus 2? It's the same thing as plus negative 2, so that gives us x equals negative 8. Are we done? Have I taught you nothing? No, we're not done. We must check. So we're going to pop this solution back into the original problem. We're going to put those brackets back up, and we're going to say 4 plus 2 equals 6. So this is the absolute value of 4 plus 2 equals 6. And this is the absolute value of negative 8 plus 2 equals 6. That's going to give us 6 equals 6. When we drop absolute value brackets, well, let me rewind. When there's only one term inside those brackets, that's when we are allowed to drop them, okay? We can't drop it right here and say 4 plus 2 equals 6. We have to continue on, combine like terms. We get the absolute value of 6 equals 6. Drop the brackets. 6 equals 6. Yes, that is correct. So x equals 4 is one of our solutions. We'll try it with negative 8. Negative 8 plus 2, that's going to give us the absolute value of negative 6 equals 6. We've got one term inside the brackets. We're going to go ahead and drop them. And what happens when we drop absolute value brackets? I'll tell you, it's like a little miracle. Anything negative inside becomes positive. So the absolute value of negative 6, because it is 6 units away from 0 on the number line, becomes 6 equals 6. Well, hot damn, we did it. Both of these solutions work. So the solution to this problem would be 4 and negative 8. That is the solution set. Great job. All right, let's do another example. X minus 9 equals negative 7. So we're going to branch out and write this twice. Drop the brackets and write it as is. X minus 9 equals negative 7. And x minus 9 equals, now what happens when we negate a number that is already negative? That's basically saying a negative 7. What's negative 1 times negative 7? It's positive 7. All right, and now we'll solve. So we'll add 9 and add 9. 9 and negative 7 is going to give us x equals 2. And we're going to add 9 and add 9. And this is going to give us x equals 16. So now we have to test both of these. The absolute value of 2 minus 9 equals negative 7. 2 minus 9 is negative 7 equals negative 7. Now if I drop these brackets, that negative number is what? Going to become positive. So now I have positive 7 equals negative 7. Well, that is not true. So x equals 2 is not a solution. X equals 16, let's try that one. The absolute value of 16 minus 9 equals negative 7. Okay, and this is going to give us positive 7 equals negative 7. Drop the brackets, this is going to stay positive. This problem has no solution. So sad. But you know what happens. Neither of these options work. X equals 2 and x equals 16. Neither of them work, so this problem has no solution. We had two winners up here. Big old goose egg down here. Sorry about it. All right, moving right along. These problems were set up to branch out to the two solving equations right away because the absolute value expression, or the thing in the brackets, was by itself on one side of the equal sign. Okay? If you have the absolute value expression alone with no outliers outside of those brackets, then you're ready to go. Branch out. If that's not the case, you need to move things around to isolate that absolute value statement before you branch out. So your steps when you're thinking about isolate if you need to, then branch, then solve, then check. Isolate, branch, solve, check. The problems that we had on this side of your notes, x plus 2, there was nothing else here. It was ready to go. X minus 9, nothing else attached to this statement. It was ready to go. We had no isolating to do, so we started right in with the branching. These examples, however, x minus 3 plus 6 equals 10, and the absolute value of 2x plus 3 times 5 minus 1 equals 14. We got to do some work here to get them by themselves before we can branch out. So this is pretty easy. There's just a constant hanging out here outside of the absolute value expression. So we're going to go ahead and move it to the other side using the inverse operation of addition, which is subtraction. Remember that? Basic math? So now we have the absolute value of x minus 3 equals 10 minus 6 is 4. Now this is the only thing on the left-hand side of the equation, so we are ready to branch out. We drop those brackets and we have x minus 3 equals 4. And we also have x minus 3 equals negative 4. Add 3 and add 3. And we get x equals 7. Add 3 and add 3. And we get x equals negative 1. Now, we know what happens when our solution here is negative. Let's see. Let's check. The absolute value of 7 minus 3 equals 4. Just shortcut yourself when you plug back in to the isolated version of the equation. You don't have to do all this work up here, the absolute value of 4 minus 3 plus 6 equals 10, because all you're going to do is move it over anyways. So you might as well just plug it into your condensed and simplified version. 7 minus 3 equals 4. This is the absolute value of 4 equals 4. 4 is the only number inside the bracket, so we can drop. 4 equals 4, that is correct. X equals 7 must be a correct solution. And let's try with negative 1. Negative 1 minus 3 equals 4. Well, negative 1 minus 3 is the same thing as saying negative 1 plus negative 3. That's going to give us negative 4 equals 4. We drop those brackets and anything negative becomes positive and we get 4 equals 4, and that works. So both of these are solutions. Our solution set, 7 and negative 1. Awesome. Let's try this last one. We got a couple things we're going to do here first. Okay. Let me give us some room. I have two operations that are happening outside of the absolute value brackets. They are subtraction and multiplication. So in order to isolate this absolute value statement, we are going to have to do the inverse operations of minus 1 and times 5. Which one are we going to do first? Well, we know for times 5, the opposite operation would be to divide by 5. Am I going to divide this whole thing by 5 and then this by 5? No, because that's going to give me the absolute value of 2x plus 3 minus 1/5 equals 14/5. Nobody likes fractions. That's a mess. So let's get rid of this outlier first. Do the easier thing first. We'll add 1 and add 1. And that will give us 5 times the absolute value of 2x plus 3 equals 15. Okay, well now we're on to something, because if we divide this side by 5 and this side by 5, we have the absolute value of 2x plus 3 equals 3. 15 divided by 5 is 3, right? These things cancel out. 5 divided by 5, because that's just 1. And 15 divided by 5 is 3. So now we can branch. We isolated, and now it's time to branch. Drop the brackets, and we have 2x plus 3 equals 3. And 2x plus 3 equals negative 3. Subtract 3 and subtract 3. We get 2x equals 0. Now what do we have to do? We have to divide by 2, right? So we're going to divide 2x by 2 and divide 0 by 2. And x equals 0 divided by any number is going to be 0. Let's try this side. Subtract 3, subtract 3. We get 2x equals negative 3 minus 3 is the same thing as saying negative 3 plus negative 3. So that gets negative 6. Now we have to do the opposite operation of what's sticking the 2 and the x together. So we're going to divide. They're being stuck together by multiplication, so we're going to do division to unstick them. X equals negative 3. Oh gosh, you guys, that wasn't even in the frame. Sorry about it. Okay. Now it's just getting comical. So now we're going to check. We are going to go ahead and check using our simplified version of the equation. Don't make more work for yourself by putting it back up into this mess. Go into the absolute value of 2x plus 3 equals 3. We can do that because the absolute value of 2x plus 3 equals 3 is the same numerical value as 5 times the absolute value of 2x plus 3 minus 1 equals 14, right? We didn't get rid of any values up here. We just did some opposite operations to simplify the statement. But simplifying doesn't mean changing. It just means rearranging to make it smaller or cleaner or however you want to view it. It still has the exact same numerical value as this. So we can check into that simplified version. the absolute value of 2 times 0 plus 3 equals 3. So that's the absolute value of 0 plus 3. 3. Drop the brackets because this is the only thing left inside. It's already positive, so nothing changes. 3 equals 3. Yes, x equals 0 works. Let's try the same thing here. 2 times negative 3 plus 3 equals 3. Lots of 3's here. The absolute value of negative 6 plus 3 equals 3. Negative 6 plus 3 is negative 3 equals 3. Drop the brackets. Anything negative becomes positive. So this one also works. Our solution set for this problem is 0 and negative 3. Okay, so that's absolute value equations. Absolute value equations. If you have questions, pause this video right now, jot your questions down on the question sheet in your packet so you know what to ask tomorrow when we start class. And we're going to move right on to absolute value inequalities. So the same rules that we followed for absolute value equations also apply for inequalities. There is one critical addition. When you negate the right-hand side of your second branch, you must also, we're dealing with inequalities here, you must also flip the sign. You have to flip the sign. So let's work this one out. The absolute value statement, x minus 3, is already isolated on the left-hand side of this inequality. So we are ready to branch. Remember that our steps, isolate, branch, solve, check. IBSC. All right. We're going to branch x minus 3 is less than or equal to 3. And this side becomes x minus 3 is greater than or equal to negative 3. So you still negate the number and you also flip the sign. Okay? So we will add 3 and we get x is less than or equal to 6. Add 3 and add 3. X is greater than or equal to 0. Now we're going to go ahead and graph this. The cool thing is with inequalities, you don't have to check because we're not looking for an exact number, right? We can check. Okay, so we could say the absolute value of 6 minus 3 less than or equal to 3. Well, this is 3. Is 3 less than or equal to 3? Yes, it is. 0 minus 3, greater than or equal to 3. Negative 3 is greater than or equal to 3. Drop the brackets, and we get positive 3 greater than or equal to 3. So both of these work. Okay? What we do have to do and what's extra is that we need to graph these things on the number line. The solution for your inequality, your absolute value inequality, when represented on the number line, will be where the two shadings overlap. Okay, so we're going to shade x is less than or equal to 6 and x is greater than or equal to 0. I'm going to start down here, 0, 1, 2, 3, 4, 5, 6. And I'll even put negative 1 and 7 on here just for good measure. So x is less than or equal to 6. We put a closed circle on 6. And we always shade in the direction of our arrow as long as, if and only if, our variable is on the left-hand side. If your variable's over here, you can't follow that rule. But if your variable's on the left, you shade in the direction of your variable or your arrow. Look at me shading with this pen. Looks like an EKG. All right, we're going to do the same thing for 0. Closed circle because it's greater than or equal to. If it was just greater than or just less than, those would be open circles. But because it's got that equal to bar underneath, we go ahead and fill that circle in. And this one, x is greater than, is pointing to the right. So we're going to shade this guy to the right. And our solution is everything that falls between 0 and 6. It's where our shading overlaps. So if you're ever just shown a picture of just a number line and asked what is the solution to these two inequalities, that's how you figure it out. You don't have to do any actual math. You just have to look and see where everything overlaps. So if you have an overlap, we can write that in what is called interval notation. And interval notation looks complicated, but it's super easy when you know what goes into it. You're going to put your variable in the middle. Well, that's easy. Our variable is x. Okay? The number on the left side of the number line goes on the left, and that means the solution on the left. So in this case, 0 is our left-handmost solution. So that would go here. We have our x in the middle. The number on the right side, meaning the solution on the right-hand side, the rightmost or the biggest solution number, goes on the right. 0 on the left, x in the middle, 6 on the right. And then we always put less than signs in between. Always. Never greater than signs. Because our problem was less than or equal to and greater than or equal to, we will also write the equal to bar. 0, less than or equal to x, less than or equal to 6. Okay? So then we can read this as x is greater than or equal to 0 and x is less than or equal to 6. It's just an easy way to write what you see happening here and what the solutions of that absolute value inequality are. So if your answers go in opposite ways, you can't use interval notation. You can only use this when your answers overlap. But when your answers go in opposite ways, you can use or between those two answers. So let's solve this one and see what happens. And this is going to be super easy because we've got just the x inside. So we're going to isolate it by subtracting 5, and we get the absolute value of x is greater than or equal to 6. So that means x is greater than or equal to 6, and x is less than or equal to negative 6. There's nothing for us to solve here now that we've branched them out, right? So then there's nothing for us to check. Ooh. So we'll write our little number line, and we'll have 0, 6, negative 6. We shade in the direction of our arrows. We're going to go greater than or equal to 6, less than or equal to negative 6. So we would just rewrite our solutions this way. X is greater than or equal to 6, or x is less than or equal to negative 6. Okay, you guys, that's it for absolute value inequalities. Make sure, and absolute value equations, I should say. Make sure you write down any questions that you have in your packet so that when we're working problems tomorrow in class, you can ask me those very specific questions and get some targeted feedback. Just a little reminder, if you look at your calendars, we will do some absolute value practice at the beginning of class, and then we're going to have a short quiz at the end. So it is critically important if you have questions that you are able to raise them at the beginning of class. So that's it, guys. I hope this was clear. I hope it was concise. If not, we'll talk about it tomorrow. And stay tuned for your next homework assignment. Great job, you guys.